Hello viewers, welcome back to my channel. This is John from Cloud Tech Insights. Today's topic is again on Amazon Bedrock series. Like I promised, I'll be working on another session on building a chatbot using Lanchain, Bedrock, and Streamlit application. In this demo, we'll be looking at building the chatbot on a knowledge base, which is using text embedding to vectorize the document so that you can ask any question against the document and the chatbot will be able to answer the question. So this is one among the many use cases. This is a very common use cases that you see across the industry, or like any demo you see this chatbot feature, but I'm going to club in the knowledge base, the Langchain and Streamlit application, and we will look into some of the models that we can swap and try in Amazon Bedrock. So before we move on to the demo, I want to say please subscribe my channel for the latest update. Please like the channel if you enjoy the videos. This would really help me uh, make more videos on Bedrock. And before, again, another notification is understand the cost related to playing with Bedrock. These are on-demand models, so there are different cost structure to it. So understand before playing with any models on Amazon. So let's get started. So today's demo will be on Amazon Cloud9. You can use your IDE of choice, but in this example, I'll be using Cloud9. And before getting into the demo, I want to say that I've installed the corresponding requirements. And some of these are overlapping or some of these are extras, but I would say these libraries are required for some of these demos. So I will put this into the GitHub under the folder called setup or the environment setup. That way you can just call the pip install and do the requirements.txt and it will install all the information here. So let's start with creating the library or the LangChain part of it, and then we can get into the Streamlit part. So with the LangChain part, what we are doing is we are trying to import libraries that is related to the conversational AI or conversational chatbot part of the LangChain. So that's why we have the conversation buffer, window memory. Then we import the Bedrock libraries, which is related to Bedrock and calling the models related to Bedrock. And then we talk about the conversational retrieval chain. So this is where all the conversation, the workflow, the flow of the whole conversation is handled. And then we call the Bedrock embedding. I think this is a new addition from Amazon where it can call the Titan model to text embed some of the documents that you provide, and it forms the knowledge base in memory. So don't get mixed up with the vector database versus embedding. So this is one of the text embedding model, and it's running on Titan. And then comes the vector store index indicator. So once the vectors are created, then it has to be indexed in memory, again, text model. So this is another library that within LangChain that helps with the process. And next one is importing the face library, which is a library by Facebook AI similarity search. So this is help you figure out what is the best response from within the document. So it will look for those similarities, and it's a library from Facebook. And then some of the library to split the document, and especially a library to load the PDF file into the vector store. So we need a PDF loader. So just want to tell you that's one of the inspiration from one of the Amazon samples, one of the workshops. So that really helped me customize it to this demo. So at a high level step, we are configuring and initializing the language model. Like in my previous demo, I've shown how to initialize it. And then we are creating a vector store for document retrieval. So I'm using the document called, it's a research paper on cardiovascular disease. And this is the research paper. And it's basically talking about overview of cardiovascular research and what's the trend. It's a publicly available paper which is published in 2007. So it is pretty old, but just keeping, we're just using one of the sample. You can use your sample of choice, but in this, we're talking about cardiovascular disease here. Okay. Moving on to the library. The first method that we are creating is to initialize the model. So basically, we are setting the configurations. So this is a configuration for Anthropic Claude V2 model. Like we discussed in the previous one, you can always tweak some of these configuration to get the best response back. Okay. And we have emptied the stop sequence so that it produces all the information, and then we can do a good response from the output. And here we are calling the Bedrock model, which which is from the Lanchain, which is right here, and then providing the model ID and model configuration, and it returns the large language model as an object. And then comes the vector store. So this is where the Bedrock embeddings comes into picture, and I'm going to be focusing on providing the document here. So in this section, we'll be dealing with one of the local document, which is the cardiovascular disease document. So this will be the PDF path, and the PDF loader will load the PDF file into it. It splits the data using some of the delimiters and separators, and then we can provide some of the chunk size, all these information, so that it can create a vector out of the recursive characters text splitter. And once a vector is built, the next step is the create conversation memory. So we want to ensure that it has all the context of the previous information. So Lanchain as a library which maintains some of the memory, some of these conversations. In the future, I would say if it's a enterprise level application or production level application, I would highly recommend storing it in some of the database store, NoSQL database store with quicker retrieval. But in this example, we are using a local in-memory option, which is provided by Lanchain. And then comes the initializing the model and capturing all the information, the vector, the chat memory. And once the information is with the context, the chat history and context, it responds, and we provide the response back into the console. So this is where we are building a library to initialize a model, create a conversational memory, and generate a chat response, as well as creating the vector store. So what we're going to use is we're going to go to the next one is the Streamlit library app, how to build those application using Streamlit library, and then show how we can initiate a chatbot, a visual chatbot. And that Streamlit app would be calling this library here, and then hitting some of these methods and producing the output in a visual manner. Next comes the Streamlit application. So we'll be building a Streamlit application, and this is the visual interface of the chatbot. And this is an exact copy of what Amazon samples have regarding one of their workshops. I just copied it so that I can show step by step how it's created. So basically, you import the Streamlit library and the library just you worked on, and then you create the a page configuration, what the title should say, etc. You can tweak it based on your preference or based on your company name. And then first is it checks for the memory to see if there is any conversation memory. If it's not there, it wants to create completely new. So this is where the library is being pulled. So remember, like the create conversation memory, which is coming from this library right here. So it's basically creating the chat history and the messages and everything. So this is where it creates those memory if it's not available in the beginning. And then moving on to the chat history, if there's no chat history, it creates an empty Python list. So that's what it checks. And then comes, it checks for the vector index. If the vector index is in the session state, if it's not in the session state, it starts creating those vectors, which means it reads the PDF file, convert that into a vectorized style, and store it in memory. So that's what this section is doing. And then comes the message. So it's capturing all the messages, putting it into the chat message option, and that way you can capture all the information from the chat window. And then based on the input text, it calls the model, the generate chat response. It provides a test, the input text, the vector database that is created within the session, and the chat memory. So everything is created within this session. So that's the beauty. Once the session is terminated, all the vector, the memory, the input text, it's all cleared. So that's something you have to keep in mind while playing with the Streamlit application. So once this application is ready to go, what you do is you go to the folder and open a terminal within the folder. Okay, so this is how we run the Streamlit application. Give me a second. So this is how you run the Streamlit application. You say Streamlit run the particular application, which is a local application written in Python, and then you mention the port. So it can be 881 or 880, doesn't matter, as long as you have the port exposed in EC2. If you're running on EC2, may ensure that the port is exposed, or if you're running local, you'll be fine. In this example, even though I'm running on an EC2, which is on top of Cloud9 or underneath Cloud9, I am going to open this locally. So I don't have to worry about opening different port number or etc. The port is already in use, so we can play with a different port, 881. There you go. So now it's initializing the Streamlit application, and it will be available locally in your Cloud9. So it takes a few seconds to come up, and it is not calling the libraries yet. So once it start initializing, once you start opening up the UI, you will start seeing those indexing part. So let's give it a few seconds. There you go. So now you have the network URL and the external URL. So in this, if you're looking out, opening this URL outside EC2, I think you should be using external URL. If it's internal, you can use this URL right here. So it's on port 881. And instead of going out and opening this portal, there's an option within Cloud9, which is under the preview section. I can preview the running application, which is running local here. So that's what I'm doing. So if you look at this is how the application should look like if you're opening on any kind of browser outside. You should have the EC2 IP plus the port number, and that's how you can open this application. So this is the chatbot, a very basic chatbot, and you can see how you can chat here. You can put in your question. I'm going to ask I want to understand a very fundamental question. I see CVD being repeated in the research paper, so I want to say, what is CVD? So let's see if this can answer based on the document that is provided plus the information that the chatbot is trained on. So look at this. So it provided a decent information about the CVD here. And then I want to explore what are the different trends in CVD surgery. So this is a question. It's going through the document and seeing what is the best fit response along with the LLM train. So if you look at it, hey, based on the content, these are the different trends here. Search into surgery, constant heart valve replacement, working on beating hearts. So these are the new trends in the research paper. What is the difference in CVD between developing and developed economy? Let's see if we can answer this question. So the good part of a RAG-based approach is you have a factual document, and the LLM is trying to look for answers within the document. If it's not available, it comes back and say, hey, I don't have this information. So there you go. So these are like the research on the CVD difference between developing and developed nations. So who is the CEO, or let's say who is the President of United States? Let's see what the response is. This is completely out of context. So if you look at the response, it says, I do not have the context to provide the information about the current president. So this is what any enterprise or any company wants. If it's not in the document, it should not answer the question. So in that way, you are building the confidence with the users or the customers that interact with the RAG-based approach. So this is the beauty of RAG-based approach. This is how we say what to respond is the RAG, and how to respond is more of the fine-tuning and training the model. So with this, I'm concluding my demo. In the future demos, I will also show how to tune the model a little bit to see how it responds. The what part is handled by the RAG, and how it responds is something tuning can help. Tuning the model. Also, some additional videos on Lanchain, how it interacts with Lanchain, etc. Like I said, Chatbot is one of the use cases. There are other use cases with generative AI, and soon you will see more videos on it. So please subscribe and like the channel, and in that way, that's more of an encouragement. And also keep in mind there's a cost associated with playing with some of these models, so please be aware about those costs. Okay, thank you everyone. See you in the next video.